I'm Dustin Reynolds, and we're here today in the Applied Cutting Solutions facility in Ferndale, Washington, and we're here to talk about vacuum hold down. One of the common issues that I hear about is parts moving on the table, and a lot of these issues can be resolved through some proper setup and through proper programming. So first, we want to talk about what vacuum hold down is. We need to get our part to be held down harder than the router bit that's pushing on it, or our part is going to move. So let's talk about ways that we can increase that hold down and minimize that side force so we can maintain our parts held down to the table properly. So the first thing you want to do is make sure that your vacuum zones are only on in the areas that you're using them. You also want to make sure that you've got gasket tape underneath your spoil board to the edge of it so that your vacuum is going to be going to the bottom of your part. Once you've got your zone configuration set up correctly, then it becomes a matter of proper programming. Now there's many things that you can do in your programming, from using the smallest tool for the application to the strategy that you use when you're outputting it. So let's kind of go down how I would set up a job to cut many small parts out of this sheet right here. The first thing I would do is I would make sure that all of my parts are going to have a ramped lead-in. And that ramp action is going to come around the part this way, and as it moves, it will help separate that skin at the very end, thus kind of giving us a little artificial tab. The second thing I would do is make sure that all of my lead-ins are located on my sheet in such a manner that they remain consistent with the sheet. A lead-in right here means that when I come around my part, I will separate my part from the sheet early, and all of my router bit force will be pushed onto this little area. So I would put my lead in here or here so that when my router bit pushes, it pushes on both sides evenly. The next thing, if I'm still having trouble, is to do it in two operations. I would do the first pass where I would cut through 90% of the thickness of the material and leave a skin at the bottom of, say, 10 or 20 thousandths. Then take a smaller router bit and come in and take out that last 20 thousandths and do my separation pass. That way I have a small bit pushing on a thin amount of material, and all of that is going to reduce my side force on my part. If none of that works, then you're into tabs and tape. And I hate using tabs and tape. So we'll do all we can to get these parts to hold down here, and I'll show you some examples as they practically happen. I've got the machine set up now to cut out some 4-inch squares out of die bond. And we're going to set it up using the practices that I just outlined and kind of talk over it as it's going. So the first thing it'll do is I've moved the lead-ins to the middle of the sheet. I've done a ramp lead-in, and I'm also doing it with an onion skin pass. With these things in mind, we should get the maximum hold down force to our part for the longest amount of time. So you can see the ramp as it comes in, and that the lead-in is pushing on both sides of the sheet. So as you can see, with proper programming, all things are possible. There's no tape, no tabs, and no cleanup required for all of these parts to be cleanly cut out on the machine. This is 25 4-inch squares, all of them ready to go. I'm Dustin Reynolds with Applied Cutting Solutions, and this is your reminder that with programming, all things are possible.